Welcome to the iSet Robotics into Gear on your marks overview of this MOOC. In this overview, we want to tell you a little bit more about the structure of this MOOC as well as the resources that you need in order to participate successfully in the MOOC. My name is Tanya Karp and I am one of the instructors of this MOOC. In this first lecture, I want to give you an overview of the course content and the course organization. I then want to talk a little bit about LEGO Robotics. What is LEGO Robotics? How does it relate to engineering and computer programming? We'll talk about robotics mentoring because as part of this class, we expect you to mentor a group of learners in robotics. And we then give you an overview of robotics competitions that are readily available in South Africa, because after completing this class, your learners might be interested in participating in such a competition. So let's take a look at the course content and organization and also at what we expect from you throughout this class. Now, the course objective is that you will gain knowledge in robotics and you will gain skills. You will obtain those skills by actually performing robotics assignments and reporting your progress on them to us. You will also learn the engineering design process, which describes how engineers design a product that solves a given task. In our case, that's the robot, building a robot that can complete certain tasks and has certain skills. And you will learn computer programming through robotics because the robot needs to be programmed and there is a software environment that allows you to tell the robot what to do. Now, you will participate as part of this class in a robotics competition. Actually, you will be the mentor for a group of learners that will participate in the competition, but the competition is part of this class. You will mentor a group of learners once a week, and you will coach these learners in that robotics competition that I talked about and for which you will hear details later. You will improve your information technology and computer skills, since in your assignments we asked you to create short video snippets to upload them. You will interview your learners, you will take screenshots. So in addition to learning the robotics software and how to use it, you also will improve your general IT skills. And we hope that you will become an active member of the robotics community and at the end of this class are so convinced of robotics that you will stay involved and keep mentoring a group of learners. So let's have a look at the schedule of the class. This course is a UNISA MOOC and it consists of 4 learning units. Each learning unit has a video in which we explain a new robotics concept. It has a list of tasks that you need to complete, and it also has 2 different sets of activities. The coaches' activities relate to mentoring a team of learners and to reflect about your mentoring experiences as well as to prepare for your sessions with your learners. And the learner activities relate to learning new robotics skills, and those are executed by your team of learners under your supervision. So let's look at what LEGO Robotics is. In this class we're using the Mindstorms EV3 kit. And that kit comes in a box and it consists of beams, bricks, axles and wheels. It has motors, sensors and a programmable brick. And from this kit you will need you will design a robot and program the robot. So in addition to the kit, which you're responsible as a student to acquire yourself, the kit is not provided to you by the class, but in addition to the kit, you also need to have a laptop or a computer on which you then install the software. The software is for free and you can download it from the internet. And then you also need to have classroom and storage space. These are the electronics of the class. In the center of the picture, you see the EV3 brick that we oftentimes call the brain of the robot. It has a rechargeable battery that is attached to its back, and please keep it inserted once you've inserted it. On the top of the brick, you see the 3 motors. Motors are outputs and allow the robot to act and move. And then on the bottom of the EV3 brick, you see sensors being connected. We have a touch sensor, a gyro sensor, a color sensor, and an ultrasonic sensor. And we will look into those sensors more later on, but basically through the sensors, the robot can experience its environment. So how does robotics relate to engineering? Well, there is the engineering design process, which is the methodology to design a product, in our case, a robot. As you build the robot, you will learn concepts of statics and dynamics. You will see how the center of gravity and the weight distribution of the robot affects its performance. You will use axles, wheels, pulleys, learn vocabulary in engineering, and see how to build simple machines. There are gears, gear ratios, power and power transmission concepts. And finally, we will also see how friction and traction affects the robot performance. Robotics also relates to programming. You see a picture here of the programming environment. So it's a graphical programming environment. And throughout the class, you will learn decision making through switches. What do I do if I see a white surface as a robot or a black surface? You will learn about repetition in loops. How can I do a certain action several times? We'll talk about variables, constants, procedures, and multitasking. Isn't it cool if the robot can play music while it's dancing on a dance floor? So why would you want to engage in robotics? Well, through robotics, you and your learners will gain critical thinking skills and you will learn to problem solve. Basically, you will have to make mistakes and learn from your mistakes. You will also learn the mechanical design. You will apply math and sciences to robotics. You will apply the engineering process. You will learn to program. You will work as a team. There will be leadership and teamwork requirements. You need to learn your time management. And most important of all of them, there should be a lot of excitement in your robotics curriculum. So you see, well, robotics implies all the STEM disciplines, science, technology, engineering, and math. It also teaches what's called 21st century skills, like problem solving, critical thinking, higher order thinking, teamwork, and time and project management. So regardless of what career your learners will go into once they graduate from high school, there are important skills that they learn through robotics. So let's talk about the robotics mentoring a little bit, because I've already mentioned that we want you to apply your learned knowledge to the mentoring session. So you need to find a group of learners with whom you're meeting once a week. So as a target audience, you should find learners that are aged roughly between 10 and 16 years old. However, we recommend that your learners are similar in age. So maybe like all of them are between 10 and 12 years old, or all of them are between 14 and 16 years old. Your learners should have time to participate in weekly robotics sessions, and those sessions should be between an hour and a half long. The learners will work in teams of 4 to 6 learners, and they all should be committed to learning and to attending the robotics session regularly. So your task is to find a group of learners, at least one group or several groups, and sign them up for a robotics course for the duration of this class. So what do you need for your learners? Basically, each team of your learners needs to have the same equipment available as you need for the class. So per group of learners, you need one Lego EV3 core set. You need a computer or laptop with the software installed. You need table space. And you need storage space for the EV3 kits and laptops. If you're teaching or mentoring robotics for the first time, you probably do not want to engage more than 4 teams of learners. And also you are limited by the number of kits, the number of the resources that you have, because you need to acquire those EV3 kits, robotics kits. They are not supplied to you through this class. However, you're welcome to share your kit with your learners as long as the schedule allows. So how can you do this? How can you teach immediately what you have learned in the mentoring session? Because you might feel that you're still struggling with the content and that you don't really know enough yet. So my advice is, don't try to be the star on stage. Don't claim that you know all the robotics content already, but rather be a guide on the side. Guide your learners to acquire the knowledge. Keep in mind, it's okay not to know the answer. Throughout the class, we'll teach you to learn on your feet. There will be many occasions where you don't know the answer. You can always approach us and ask questions. You can make it a homework assignment. Oh, we're having a problem. We don't know how to solve this right now. So let's all go home and see if we can find an answer on the internet, Google it, or see if you find a YouTube video. And then hopefully by the next session, you have a solution to the problem. I know that you're used to teaching. However, in robotics, your major role or primary role is not really to teach, but to facilitate learning. And in order to facilitate learning, you can give your learners the task to find information. You don't need to provide them with all the answers, but for the problem solving and the critical thinking that we want them to obtain through the class, it's important that they find information and come up with solutions themselves. Well, and then be honest with your learners. Tell them that you're currently taking this class, that you're still learning, that you're all into this together. And don't hesitate to ask your learners for help. Sometimes the problem that one team has might have already been solved by another team. Or you have a problem and your learners know the answer. Oftentimes, the learners or the youth in general is less intimidated by the software and the environment. They have a more playful approach to it. So Use their knowledge, use their curiosity to learn from them. So robotics competitions provide an outlet to apply the robotics knowledge that you've gained throughout the class and to push the envelope in a competitive environment. There are a couple of robotics competitions already in place in South Africa. Many of these are international robotics competitions. So one of them is First Lego League. It's an 8-week competition and starts in August. And it consists of 2 parts. One is the robot mission, and that's on a game field where the robot has to perform a set of tasks for a number of points. Then there is a research topic that the team needs to solve on the side that has nothing to do with the robot but is related to the topic of the annually changing competition. Teams consist of up to 10 learners, and everybody in a team must be aged 16 years or younger. Next, there's the World Robotics Olympiad. It's also an 8-week competition, and at the competition day, the team of learners has 90 minutes to build a robot and then have the robot complete the mission on a game field. There's no research project. The teams are limited to 3 learners, and they have practiced the building and the completion through the 8 weeks of the challenge. And then there's a virtual gear competition where gear stands for Get Excited About Robotics. That one runs from January through April, and it's all online. Learners do not travel but create and upload videos. They work on their robots at their local site, and it is an international low-cost competition where teams, in addition to learning robotics, also learn ITC skills. We currently have teams from South Africa, Germany, and the US participating in this annual competition, and it runs from January through April. The Rowbotham is an annual 1-day robotics event where teams have 5 hours time to complete a challenge. It is part of the Science Expo, and there is a junior and a senior challenge. In previous years, challenges have been, for example, to build a trebuchet or a warehouse challenge where the robot has to operate in the warehouse.